Hi, thank you for coming to see my presentation. My name is Chaeyong Park and I'm a graduate student at Post-Tech, South Korea. I'm going to talk about our paper, Augmenting Physical Button with Vibrotactile Feedback for Programmable Fields. Physical buttons are one of the most effective, efficient, and pervasive user interface, and which are widely used in the world. They provide physical affordance as well as natural and pronounced haptic feedback. However, a physical button represents the same feedback all the time, so it is not easy to use physical button for a programmable interface. Other type, the virtual button, displayed on the touch screen with additional vibration, offer advantages of adaptability, but they lack the physical affordance and clear haptic feedback. To improve the drawback, we introduce a haptic augmentation technique for modulating the feel of a real physical button by providing additional vibrotactile feedback. When the user presses the physical button, an actuator generates a vibration signal and it is added to the original force response of the button and presented to the user. So, in this research, we explore the vast design space of augmented button and present a structured and detailed analysis on the perceptual attribute of click sensation. This is overall design of our augmented button prototype. We use a linear mechanical switch, a vibrotactile actuator, and put them all into 3D printed housing. For vibrotactile augmentation, we design the vibration waveforms by varying frequency, amplitude, and envelope. To investigate the perceptual properties of augmented button, we conducted 2 user experiments. In the first experiment, we wanted to estimate the perceptual space that visualized the relationship between 40 vibration-augmented buttons and 7 physical buttons. As a result, the buttons are widely spread across the 2D perceptual space by multi-dimensional scaling analysis. The base button number 41 is represented with a star, and the distance between 2 points means the perceptual dissimilarity between the 2 corresponding buttons. Also, according to the result of clustering analysis, the buttons are classified into 4 large groups. From the results, the vibration frequency and envelope has a critical effect. For example, the left and right group have different vibration frequencies, and the lower group have different energy. Interestingly, envelope shape and amplitude are much less important. In the second experiment, we tried to figure out a coordinate frame that can explain the point distribution of perceptual space with linguistically meaningful words. We selected 10 words, and then participants rate the subjective sensation of each button reflected in the words. As a result, we find the 10 axes which represent the button feel in the perceptual space. For example, button number 8 gives hard, a sticky, and blunt feel, and the button number 20 gives a sharp, shallow, and light feel. Then we recommend the sharp, blunt, and soft, hard as the 2 perceptual dimensions for the 2D perceptual space of button click feel. We can understand the perceptual relation between various augmented buttons, and this is similar to the HSV model for color perception and representation. Simple and easy vibration augmented button can be used in many interaction scenarios. We can design context-dependent button, state of the system, effective interfaces, and immediate system response to the user. The contribution of this work are structured and detailed analysis on the perceptual attribute of vibration-augmented physical button. This is end of my talk. Thank you for watching it.